want to use the uniqueness of the momentum or moment generating function to give the distribution of a random variable with moment generating function mt equals 0.6 et plus 0.43. All right. And remembering that the moment generating function that I derived earlier was mt is equal to p to the et, or p times e to the t plus 1 minus p all over, or all to the n power. So let me just write that down. mt is equal to p e to the t plus 1 minus p, also known as q, to the n power. And comparing this to my function that they were giving me, 0.6 e to the t plus 0.4 to the 3, it's kind of obvious that the p that they're giving me is 0.6, and the q that they gave me is, well, 1 minus p, which is also known as 0.4, that's a good thing because this is 0.4, and the n is equal to 3. So I think that what they're asking for is a binomial probability with a with n equal to 3 and p equal to 0.6. So I just plug that into my equation. So I have p of x is equal to n factorial over x factorial times n minus x factorial, p to the x, 1 minus p, n minus x. So I just plug that in, those numbers in, and so I have 3 factorial over x factorial, 3 minus x factorial, 0.6 to the x power, 0.4 to the n minus, or I'm sorry, 3 minus x. And so for whatever probability it is you're trying to find, this is the equation to use. And n equal 3, p equals 0.6. That would give me an expectation value of 3 times 0.6. And I apologize, I didn't do that off the top. I didn't do that equation yet, but I think that would be what, 1.8. And let's see, the var of x, that's whatever that would be 3 times 0.6 times 0.4. So whatever that is. And I honestly, off the top of my head, without my calculator, I don't know if I can figure that out right now. All right, let's do this problem right here. And basically it says, if y has a moment generating function of this, whatever that is, what is the p of y greater than or less than or equal to 5? So here's the way I would go about that. Comparing it again to our general moment generating function, I think I can tell that p is equal to p was equal to 3 or 0.7 in this case, and n is equal to 10, right? Because the exponent is the n. Okay, cool. So what they want me to find is p is less than or equal to 5, or p, the probability that y is less than or equal to 5. What I would do is I'd probably look this up in a table, and I think there is a binomial distribution table for n equals 10 specifically. So if I go here, this is straight out of our textbook in Appendix 2, table number 1. This is saying for p of y is less than or equal to a of p of y, and if n were equal to 10, then this is the a that I would use. So I wanted a equal to 5, and I'm looking at 0.7, so I would say my answer is 0.150. So that's equal to 0.150. Yeah, that was just straight up table lookup and another application of this moment generating function.